Okay, so we're going to solve growth and decay problems. We're going to look at revising solving natural exponential equations, reminding you what the natural exponential and natural logs are. Again, if you've got the little orange book, chapter 15 example 5's got a good worked example plus other questions for you to try. If you've got one of the big blue books, it's exercise 15H for you. Okay, a wee bit of background. There's a special number E, approximately 2.718, which is very important in maths, particularly when we're doing logs and exponentials. When we're talking about growth and decay, quite relevant just now. The function f of x equals e to the power of x is called the natural exponential function. You've seen ones that have been like 3 to the power of x, 4 to the power of x, and so on. And the log ex is a natural log, although it is written shorthand as ln of x, and that is the button that appears on your calculator. It's worth remembering at this stage that e to the power of x and ln of x are inverses of each other. Remember, the exponential and the log are inverses of each other. So we're going to use that in practice. So solve the equation e to the power of x equals 9. And we're going to start by taking natural logs of both sides. The reason for that being is if you think of the example, sine x equals a half, what you would do is sine inverse. And that's essentially what you're doing here. You're technically taking sine inverse of either side, and that would get rid of your sine, but obviously brings it in over the other side. When you're applying that to logs, two ways you can think about it. I tend to like to put in ln on either side, so I would tend to go ln, and then what does happen if we're going to explain it properly? That jumps down at the front and you get x ln e equals ln 9. It's worth remembering here that ln 9 is just a number, and then ln e, that is log e to the e, which is 1, so that disappears. So in short, what we can do is, if I take all of that back and I do e to the power of x equals 9, and I put in my natural ln's of either side, what I tend to do is say that eliminates each other, and it leaves you with x equals ln 9. You can leave it like that, but if you want, you can put it into your calculator. Just going to grab mine. ln 9 gives you an answer of, to one decimal place, 2.2. But I would probably leave it in that form. Okay, next example. E to the power of 5x plus 1 equals 20. So again, first step is going to be taking ln of both sides. So ln on either side, in fact I'll just rewrite it. So ln of e to the 5x plus 1 equals ln of 20. And again, those battle each other out, and I'm left with 5x plus 1 equals ln of 20. Now you can solve it with ln 20, so 5x equals ln 20 minus 1, so x is ln 20 minus 1 over 5, and that comes out as ln 20 minus 1 divided by 5. It's 0.399, so you could write it to one decimal place as 0.4. Likewise, what you could do is, if you don't like the ln 20 bit here, you could change that to a decimal, which is 2.99, so we'll round it to 3 to make life a bit easier for ourselves. So that would give you 5x equals 2, x is 2/5, which is the same as 0.4, but either is fine there. Okay, have we got those two? Pause the video. I am going to work through the answers. What you should have got here was x equals ln 5, and if you'd worked that out, ln 5 is 1.6. This one here, you're going to need to divide by the 4 first. So I'm going to get e to the 2x equals, well, 1.2 divided by 4 is 0.3. Then natural logs of both sides, fire them in, ln 2x is ln 0.3, x ln 0.3 divided by 2 gives you negative 0.6. Okay, that's your core skill. Kind of in summary, what do you want to do? You want to get it as e to the power of x, or e to the power of whatever x equals. Then you want to take ln of both sides and solve. Okay, right, let's apply this into context then. So, here is a contextual question. Scientists are studying the growth of a strain of bacteria. Number of bacteria is present, given by the formula B of T equals 200e to 0.107 T. T is the number of hours since the study began, and B of T is the number of bacteria after the certain time period. So, state the number of bacteria present at the start of the study. Well, at the start of the study, your time equals 0. So, B of 0 is 200e to 0.107 times 0. Hopefully you remember that anything to the power of 0 is 1, so that's 200 times 1, which is 200. Okay, part B. Calculate the time taken for the number of bacteria to double. Okay, well, we started off with 200. This is our bacteria after a certain time. Double 200 is 400. So 400 equals 200 e to 0.107 t. We're going to work out what t is. I'm going to divide both sides by 200 to get e by itself. That's going to give me 2. Sorry, I've written 20. 2 equals e to the 0.107 t. I don't really like it like that. I'm just going to flip it around. So e to the 0.107 t equals 2. Now I'm back where I was before. Take ln of both sides. That's going to give me 0.107t equals ln2. And then t ln2 over 0.107, and that comes out, I'm sure, 6.5. I'll just double check. Yes, 6.47, so 6.5 years. Okay, marks for that. 1 mark for 200. You get 1 mark for substituting in, 1 mark for getting the equation equal to 2. Oops, I've jumped a step, sorry. The 3rd mark is for taking logs of both sides, and the 4th mark is for your final answer. Okay, we've got 3 to look at. Next one, 2019, electricity in a spacecraft can be produced by a type of nuclear generator. The electrical power produced by this generator can be modelled by this equation. P of T is the electrical power produced after T years. Part A, very similar. If you want to pause the video, have a go just now. Okay, well, like before, P of 0 is going to be 120. Okay, you put 0 into that, it's going to be 120 e to the power of 0, which is just 120. Okay, part B. Calculate how long it takes for the electrical power produced by the generator to reduce by 15%. Okay, well, this is the power after a certain period of time. We want to know what happens when it reduces by 15%. So what we're going to do, 15% of 120, what's that? 18, so it's going to be 100 and, no, not 18, is that 18? Yeah, 18. Oops, let me rewrite that, it's a bit messy. 18, so what's left is 120, take away 18, which is 102. So we're going to have 102 equals 120, I'm going to fix that equals sign. 102 equals 120 e to the negative 0.0079t. What actually happens when you divide both sides by 120 is you get 0.85. Now that you can actually go straight to this step here, because if it reduces by 15%, it means there's 85% left. 85% left as a decimal is 0.85. Likewise again, flip it around. I'm going to get e to the negative 0.0079t equals 0.85. Take the logs of both sides, I'll just change the colour here. That's going to be negative 0.0079t equals ln 0.85. Just remember, when you do the logs of both sides there, those eliminate each other. Okay, so we'll get t is ln 0.85 all over negative 0.0079, and that comes out, I'm sure, as 20 point something. Right, by negative 0.0079, 20.6, and we are working in years. Okay, right, we're going to look at another problem that involves something called half-life. So this quite an old question. The amount AT micrograms of a certain radioactive substance is given by this equation. AT equals A naught e to the power of minus 0.002t. A naught is the amount of bacteria present initially. So what are we told? If 600 micrograms are left after 1,000 years, how many micrograms were left present initially? Okay, so what we're told is that 600, part A, 600 equals A naught, we're going to work out what A naught is, e to the negative 0.002, and it's multiplied by 1,000. Okay, so we get 600, so we kind of kid on this A0 is a letter, like an X. A0, and I'm going to put that straight into the calculator. E, so if you press alpha, then the times 10 to the pi button, times 10 to the power button, e to the power of negative 0.002 times 1,000. That gives me 0. We'll go for 3 decimal places, 135. To get A0, I'm going to divide both sides by that decimal, 0.135. What does that give me? 600 divided by 0.135. We're talking 4,444. So 4,444 micrograms mg. So, part B. The half-life of a substance is the time taken for the amount to decrease to half its initial amount. Okay, well, our initial amount is this 4,444. So our new bacteria is going to be 2,222. Equals, now we know what A naught is now, so we can sub that in this equation here. So it's 4,444 e to the negative 0.002t. And we're going to work out what t is. Now the thing is, with the doubling one we did before, when you get your equation, e to the power of something is always going to be 2. This one, because we're talking about half-life, is always going to be equal to a half no matter what numbers are there. So if I divide by 4,444, I'm going to get a half equals e to the negative 0.002t. Again, take the logs of both sides. I'm going to flip it around first, sorry. E to the negative 0.002t is a half. That is negative 0.002t is ln of a half. So just put a wee arrow up here. No, actually I'll just continue down. So what have I got? T is ln of a half all over negative 0.002 into the calculator. Ln of 0.5, probably easier putting that in, divided by negative 0.002. I have got 346.6 years. So it takes 346.6 years for the bacteria to decay. Okay, in terms of marks for this one, did I do the marks for the last one? No, I didn't. I'll jump back here quickly. Marks for this one. Again, 1, 1, 2, 3, and 4 for your final answer. This one we've just done. Again, it's 3 marks, so it's 1 mark for that. It's 1 mark for rearranging, 1 mark for your final answer, and then 4 marks for the second part. 1 mark here, second mark for the equation, third mark for taking the logs of both sides, and your 4th mark for your final answer. Okay, we've got one more to do, and it's from 2018. A supermarket has been investigating how long customers have to wait at checkout. We've got this equation here, not as nice as it's been. So we'll have a look. Part A, if 50% of customers wait for less than 3 minutes to determine the value of K. So P tells us the percentage who wait for less than T minutes. So we know it's 50%, okay, 50% of 100 is 50, equals 100 bracket 1 minus E. Now we know it's less than 3, so T's 3, so it's 3K. Now again, there's loads of ways to do this. You can multiply out the brackets. I am probably going to divide by 100 first. That's going to give me 0.5 or a half even, it's 50%, a half, equals 1 minus E to the 3K. A wee bit nasty on this one. I'm going to basically add 3E to 3K to both sides, and I'm going to take off a half from both sides. So it's going to give me E to the 3K equals a half. Then natural log of both sides again, so that's going to give me ln E to the 3K equals ln to the power of a half. I'm going to cancel them out, so it's 3K equals ln to the power of a half. That means that K is ln to the power of a half all over 3, which says in the calculator gives me an answer of negative 0.23. We'll go with that. In fact, will we go with one more? We'll go for one more. Negative 0.231. 4 marks. Again, 1 mark for setting up your equation, 1 mark for getting E to the K equals, natural logs, and your final answer. Okay, I'll leave that up there for a wee second. If you want to copy it down or double check anything, pause the video, because I'm going to clear the screen. Okay. Part B. Calculate the percentage of customers who wait for 5 minutes or longer. So we have now got the equation of P equals 100 bracket 1 minus E, and we've worked out K was negative 0.231 T. So we're saying, it says calculate the percentage of customers who wait 5 minutes or longer. So that basically means our T is going to be 5, because we'll basically use that information and manipulate it at the end. So I'm going to basically say, okay, P is 100, 1 minus E to the negative 0.231 times 5, and what's going to happen is, this is going to give us a number, so I'm going to put that straight in, 100 bracket 1 minus E to the power of negative 0.231 times 5, close bracket, and it comes out as 68.49%. So 68.5%, or 68.5. So what does that say? Well, that says 68.5% wait 5 minutes or longer. So that must mean that 31.5% wait, got that round the wrong way, wait less than 5 minutes, that's what that equation helps us do, wait less than 5 minutes, so 31.5% wait 5 minutes or longer. Okay, your marks for this one, 4 marks again, 2 for this one. 1 is basically for subbing in the information down in this step here, and 1 is for correctly communicating your answer.